Okay, so again, we're practicing our new skill here, but long term, if you see an easier out, if you see it's a geometric series, do geometric work. If you see the limit would be 0 or not 0, do the interim test for divergence. Only do this integral test for convergence if it meets the conditions. It needs to be continuous. It needs to be positive. Oops. And it needs to be decreasing. So I can see, well, first off, sine's never discontinuous. If you remember the sine graph, sine always exists, so I'm not worried about that. But 1 over n squared could be undefined if n was 0, but notice we're starting at n equals 1. So if we're starting at n equals 1, it's always continuous. If I plug in any n value in here, starting at 1, this is always positive. And then as I plug in bigger and bigger values here, pi divided by a bigger number, this just goes to 0. So I get a positive times the sine of 0, which is positive. And in the long run, it will be decreasing because as this n gets bigger, you're dividing by n squared. So it meets the conditions. Again, I know this seems silly to think about today, but if you don't know when to use this test, it doesn't really matter that you can do it. But since the conditions are being met, we can try to integrate from 1 to infinity, or 1 to b, where b goes to infinity. Now, I would like to rewrite this with u substitution. This is a u substitution question. So, what would you guess u to be? It's okay if you pick wrong. Just pick one. Okay, so if you pick this to be your u, then du would be sine of something would be cosine of something times the derivative of pi over n, which would be 1 over n is like n to the negative 1, which would also give you a negative over n squared. All right, but look, I can't ever make this substitution. I'm never going to be able to put a du there because it's got cosine, and there's no thing there. So pick a different u.
1 over n squared.
Okay, if we try 1 over n squared, then du would be negative 2 over n cubed dn. I don't see how I'm ever going to get sine stuff there. So no problem, just pick a different u. Usually when you pick u, you want to pick a u that is inside of something, right? So how about you try pi over n? Again, with u substitution, there's nothing wrong with picking the right u. Pick a u, write it down, and then take the derivative, and if the pieces fit, you're going to know pretty quick, and if the pieces don't fit, you're going to know pretty quick. Just pick a different u. Okay, so then du, this is like pi to the n minus 1 would be negative pi over n squared. I'll multiply the dn over. So now this is like cosine of, or I'm sorry, sine of u, and I need 1 over n squared and a dn technically. So I can see I want to divide this side by negative pi, so I need to divide this by negative pi. So negative 1 over pi is the undoing of the chain rule stuff, and then I can just do sine u du. You okay with how I made that switch? Okay, now one thing I do need to go and change since I didn't make 2 steps out of this. Remember 1 and b or when I was talking about n stuff, but if I'm talking about u stuff, when n is 1, u is actually pi, and when n is b, or I'm sorry, Yeah, if I plug in b here, then u would be pi over b. Okay, so of course, u substitution, that's the kind of a pain part, but afterwards it should leave you behind something that's fairly easy to work with. The derivative of negative cosine something is what gives me positive sine something. And if we evaluate this from pi to pi over b, first time we need to plug in pi over b, subtract. The next time we're going to plug in pi. So I've got a number times a limit thing, and then this is just a number. All right, so basically what's going to determine the answer to this question is how this limit's going to work out. So as b goes to infinity, this fraction goes to 0, and if this is going to 0, the cosine of 0 is 1. Add this one, so you get 1 over pi plus 1, which is not infinity or negative infinity. So this convergence, but it does not converge to that. Again, this is the fact that this is a number tells you it converges, but that's not what it converges to. We don't have enough information to figure out what it converges to. Okay. So again, looks like I'm doing a whole lot there, but hopefully you guys feel okay about the integration. I know it's been a while. The limit in the integration is literally, I mean, it's like the whole problem basically. So I guess knowing that you can do this is new to you. Knowing what the answer from integration does tells you as far as converging and diverging is new to you. But the rest of this should be reviewed. So it'd be a good chance to get some practice and be less rusty about it.